Okay, today we're going to be talking about roots and remainders. Root, remember, is another word for either x-intercept or solution or zero. But in order to do this, it is imperative that you know how to use synthetic division. And I know we didn't quite get there, so let's teach you now. All right, so let's look at an example of long division versus synthetic. And we touched on this last time, but now that you've seen it once, I want you to have a better understanding of what's going on. Okay, so for example, let's say I'm going to do let's see, 2b cubed plus 16b squared plus 23b minus 2 divided by b plus 6. So like we talked about last time, our whole idea is multiply to match. So, and I'm focusing on the first term of the polynomial. So what do I multiply b by to get 2b cubed? 2b squared. Now I'm going to distribute that. So 2b squared times b is 2b cubed times 6 is positive 12b squared. But now we're going to subtract it all. So subtract, these cancel, and I get 4b squared, and I'm going to drop the next term. Same process. What to multiply b by to get 4b squared? 4b. 4b times b is 4b squared. 4b times 6 is 24b. Now I'm going to subtract that, and I get negative b minus 2. B times negative 1 will get us negative b. Negative 1 times b is negative b. Negative 1 times 6 is negative 6. But when I subtract that, when I subtract a negative, it becomes a positive. So our remainder is 4. So my answer is 2b squared plus 4b minus 1 plus 4 divided by b plus 6, because it's still being divided and it doesn't simplify. Okay, so like we touched on last time, synthetic division is, it is dealing with the coefficients, because I can look at this and say, all right, notice how because the leading coefficient of b plus 6 is just 1, I can just deal with the coefficients every time. And here, let me phrase that a better way. Because this is just b, do you see how it went b cubed, b squared, b, nothing? Well, basically by dividing by b, 1b is coming out of all of those each time. So it becomes b squared, just b, nothing, and then the b in the bottom. And so because I know that fact, I'm going to say, all right, I know that the variable is just going to decrease its exponent by 1 for every term. And I'm going to take that, and now I'm just going to deal with the coefficients. So the way we're going to set this up, I'll explain why we're setting it up this way in just a second. I'm just going to take the coefficients. So we have 2, 16, 23, negative 2. And if we look at the pattern here, notice how this first one, because it's just by b, I'm not dealing with any coefficient in front. That first coefficient is going to carry through to my answer. So I know in this process, I'm just going to drop it. This is going to represent our answer down here. And turns out I would rather not deal with like put there and then subtract. So what I'm going to do is if I take the solution of this, which is basically, switching the sign. So here, because I know that b equals negative 6, so as a factor, if by switching this sign, now instead of like subtracting every time, I can just add down every time. But I still need to distribute, so I'm going to go 2 times negative 6, which is negative 12. And I'm going to add those together. And I get 4. 4 times negative 6 is negative 24. Add negative 1. Negative 1 times 6 is positive 6. And I get 4. Well, if you look at where did these show up? Here's the 2. Here's the 4. Here's the negative 1. Here's that positive 4. So this on the end becomes our remainder. And because I was just dividing by b every time, I always go from right to left here just because it's easier, and I know it goes constant just b squared, and I would keep going in that process. And so my answer is 2b squared plus 4b minus 1 plus 4, which is my remainder. It's still being divided by b plus 6. That doesn't change anything. So the whole point of synthetic division is to take this and just make it go a lot faster just by just dealing with the coefficients. And so hopefully you're able to kind of grasp with like, why am I adding? Why is it switched? Where is this all coming from? I hope you're at least catching on to that. And you can solidify that more next year, so I'm not too worried about it for this moment, but I did want you to see that this isn't just magic. It's not just coming out of nowhere. But what's important here to know, if I had red, I'd be writing this in red, is you can only use synthetic division when dividing by a linear binomial whose leading coefficient is 1. And you might be wondering, well, why? Why does it have to have a leading coefficient of 1? Well, let's do that by an example. And I'm going to use long division to help you see. So let's say I was doing like 2x minus 3 divided by 4x cubed minus 7x squared plus 2x plus 1 or something like that. Okay, 2x times 2x squared. So I get 4x cubed minus 6x squared, subtract it. So these cancel. I get negative x squared plus 2x. So that's going to have to be 2 times negative half x. And this is getting ugly, but the point I wanted to show you is the same. Because, you know, with synthetic division, if I was to do this where it was 4, negative 7, 2, 1, my solution here is positive 3 halves. If I was to do this with the process of synthetic division, that first coefficient always drops. But it was because I just know that the degree is going down, and because it was 1, it has to match down. It has to. Where here, you notice how this coefficient did not carry into my solution. It was something different. And so because of that, the rules of synthetic division are not applying in this situation. Synthetic division needs to drop. So this can only happen when the leading coefficient is 1. So that's why. Okay, so let's do another example, meaning let me have you try an example. Okay. I would like you to do x to the 4th minus 3x cubed minus 76x squared plus 65x minus 50 divided by x minus 10. Okay, I want you to please pause the video at that point, well, right now, and I want you to see if you can set this up and do the synthetic division process based on what I was just shown. If you're still confused, feel free to continue watching. Otherwise, I want you to pause and try it. I know that since the solution or opposite of that is positive 10, that goes outside. Now I take my coefficients, 1, negative 3, negative 76, 65, negative 50. And I always know that this last number is going to give me my remainder, so I like to put that box in the beginning. The first one drops, so I get 1. 1 times 10 is 10. Add down, I get 7. 7 times 10 is 70. Add down, negative 6. Negative 6 times 10 is negative 60. So I get 5. 5 times 10 is 50. So my remainder is 0. That means they work out nicely. That's nice. This is c x squared, x cubed, because you're just building. So your answer is 1x cubed plus 7x squared minus 6x plus 5. Okay, so that is synthetic division, and I hope you feel comfortable with that because it's going to be a lot of what we're building on today. Okay, so what we're going to do, a few things that you're going to be asked with this is something like find the remainder of something. Let me pull up a problem. Find the remainder of, let's say, k cubed plus 13k squared plus 46k plus 40 divided by k plus 8. Well, I could do long division and find the remainder that way, or how about synthetic? Because I see, oh, that is a linear binomial and its leading coefficient is 1. So I should be able to use synthetic division really quickly. So I want everyone to try it. Here, pause the video right here, and I want you to try it. Okay. It just goes so much faster, and that's why we like it. Another way that you could find the remainder is what we call the remainder theorem. Okay. So basically what the remainder theorem says is that instead of having to divide this, I'm going to